Alright, again, we're continuing on with factoring. Today we're working with difference of squares. We have learned several different factoring techniques. The first one that we learned was greatest common factor. What else do we know how else do we know how to factor? Grouping. And today we're going to learn about difference of squares. So that only leaves really three other methods that we'll learn in order to factor here. So we're on a good start here. Michael, will you put those lights off? I think it'll be a little easier to see. Just one of them. That's fine. I think it'll be okay that way. If I give you this, and you guys have this in the brown box at the top of your paper, it says to FOIL. Could you FOIL out this product of two binomials? We should. Remember, FOIL stands for first, outer, inner, last. So start by multiplying your first terms. A times A is? A squared. Multiply your outside terms. A times B. So plus AB. Inner, negative B times A is? Negative AB. We'll put it in alphabetical order. And last is negative B times positive B.
Negative B squared.
Negative B squared. Now when you simplify this, what's going to happen? The AB's are going to cancel out. And so we would just be left with A squared minus B squared. Any guesses as to why those middle terms canceled out? One's positive and one's negative. Look at this problem. They're exactly the same, except for the sign in the middle, correct? Okay. And that will always happen. That will always happen. Those terms in the middle will cancel out if you are multiplying two binomials that are the same, just different signs in the middle. That middle sign is the thing that has to be different. So what if I ask you to go the other way? What if I give you A squared minus B squared, and I ask you to factor that? Could you do it? We could. If we want to factor this, take the square root. What is the square root of A squared? Or what are we squaring in the first term? A. So my first term in each parentheses is going to be A. What are we squaring in that last term? B. One's positive, one's negative. We want one of them. We want the middle terms to cancel out, don't we? So we get the A squared minus B squared. Okay, so one has to be a plus, one has to be a minus. This is going to be our general form or general formula, you could call it, to factor difference of squares. I'm going to go through some examples here. But before we do that, let's talk about some things. Greatest common factor. When we use greatest common factor, do we have any limitations, or can we use greatest common factor anytime? Greatest common factor can occur anytime. It doesn't matter if you have 2 terms or if you have 10 terms, 5 terms, 20 terms. It doesn't matter. Greatest common factor has no really limitations as far as number of terms. But grouping, which we talked about yesterday, what were our limitations there?
4 terms.
We had to have 4 terms. Okay, we had to have exactly 4 terms. Difference of squares has its own specifications. You have to have 2 perfect squares. Do you know what I mean by perfect squares? Let's talk about that. You have that column on the right side of your notes. Let's talk about some perfect squares before we get too far. 1 squared is 1. So we consider 1 a perfect square. 2 squared is 4. 4 is considered a perfect square. What is 3 squared? 9. 4 squared? 5 squared? 6 squared? 7 squared? 49. Now remember, to get these numbers, we're taking 7 times 7, 6 times 6, 5 times 5, or maybe 8 times 8 for 8 squared. 9 squared is 10 squared. 11 squared. 12 squared. What did I go up to? 13, 15, 20. Okay. So 12 squared is 144. 13 squared. 15 squared is 225. And 20 squared?
400.
definitely a list that could help you as you go through this. Back to this slide here. It says in order to factor using difference of squares, both terms must be perfect squares, what we just talked about, and there must also be a subtraction sign. Think about the name, difference of squares. What does difference mean? Subtraction. So you have to have subtraction, and you have to have perfect squares. Now, is x squared considered a perfect square?
Yeah.
Yes. What about x to the 4th? Is that considered a perfect square? Yes. X to the 4th. What if I wrote that as x squared squared? Is it a perfect square? Yes. What are we squaring? Well, we're squaring x squared. Okay, we'll get there with some examples. But look at this first problem, x squared minus 16. Let's first decide, do we have a greatest common factor? Is there anything that goes into x squared and into 16? There's not. It has two terms, so we should automatically be thinking of difference of squares. Do we have a subtraction sign where we can perform difference of squares? Yes. So at this point, I'm going to set up my two parentheses. Difference of squares always has two parentheses, side by side. Just like on grouping, we finished with two parentheses side by side. Now go ahead and factor here. What are we squaring in the first term? What squared gives us x squared? X. Can't we square x to get x squared? Okay. What squared gives us 16? Or think of it as the square root. You could do it that way. What is the square root of 16? 4. When we FOIL this out, we would want the middle terms to cancel out, so we just have x squared minus 16. So one side needs to be plus, one needs to be minus. The next example. 81x squared minus 4. Do we have a greatest common factor? No, not in 81 and 4. There's nothing that goes into both. Do we have a difference of squares? Yes, we have subtraction. We have two terms. So we definitely have difference of squares. So what can I square to get 81x squared? 9x. What can I square to get 4? 2. One is plus, one is minus. One parenthesis is plus, one is minus. Now it doesn't matter. You could have put minus first and plus second. It won't impact anything. Go to the next example, please. 16x squared minus 36y squared. Do we have a greatest common factor? Yes. There's 2, I agree, is a common factor, but it's not the greatest common factor. What is the greatest common factor? 4. Let's take a 4 out of everything. We have to do greatest common factor first. It's a must. So greatest common factor, how many parentheses do we have? 1. Now, I will see a lot of people make this mistake. They're going to want to do greatest common factor and difference of squares at the same time, and you can't. It needs to be a 2-step process. We do greatest common factor first, and then the next line will take care of difference of squares. So factor out of 4, 16x squared divided by 4 is? 4x squared. 36y squared divided by 4 is? 9y squared. 36 divided by 4 is 9. So at this point, all we've done is greatest common factor, correct? And that should be something we are familiar with. Now, looking inside parentheses here, in that expression that's inside parentheses, can we go further? Can we still factor this? Yes. What method can we use to factor this? Difference of squares. Do you see that? We have subtraction. The first term's a perfect square, the second term's a perfect square. Michael, you with us? So let's go ahead and factor using difference of squares. Set up 2 parentheses. What is the square root of 4x squared? 2 what? 2x. What is the square root of 9y squared? 3y. I would be looking for all 3 of these expressions in your final answer. You had to factor out the 4 first, so we bring that down out in front. The parentheses here and here are difference of squares. Those are important as well. Just as important as that 4 is that we bring out front. We just brought that term down. For this example, do we have a greatest common factor? Yes, what goes into 100 and 225? 25 does. You might say 5, but is 5 the greatest common factor? No, it's a common factor, but not the greatest. 25 is the greatest common factor. Remember when we do greatest common factor, we have one parenthesis. So go ahead and divide. 100a squared divided by 25?
4a squared.
4a squared. 225 divided by 25? Minus 9. Have we factored completely? No. What's in parentheses can be factored further because we have a difference of squares. So bring down your 25 and set up your 2 parentheses for our difference of squares. The square root of 4a squared is 2a. The square root of 9 is 1's plus, 1's minus. Again, all three of these expressions, 25, 2a plus 3, and 2a minus 3 are important. They're all part of your answer. This example. Do we have a greatest common factor? I don't believe so. So, do we have a difference of squares? I'm thinking 2 terms, difference of squares. Do we have a difference of squares? Is 625 a perfect square?
Yes.
Let me show you something real quick. If you are unsure if it's a perfect square or not, you could go to your calculator and type in second square root of, was it 625? Okay. And then hit enter. And it'll tell you if it's a perfect square or not. It'll give you a nice integer number if it is. If it gives you a long decimal, then it's not a perfect square. So we know that 625 is a perfect square because the square root is 25. So let's go ahead and set up our 2 parentheses. We deemed that their word was not a greatest common factor. What is the square root of 625? 25. We just found that. What is the square root of 49y squared? 7y. 1 is plus, 1 is minus. Now this next example, we have x to the 4th minus 625. Obviously no greatest common factor, right? Do we have a difference of squares?
Yes.
Is x to the 4th a perfect square?
Yes.
Because remember, like I told you a second ago, we can write it as x squared squared, correct? 2 times 2 gives me 4 if you know your exponent rules. We do have a difference of squares, so we're going to factor it as such. What is the square root of x to the 4th? X squared. Or what are we squaring? Or we are squaring x squared. What is the square root of 625? 25. 1 is plus, 1 is minus. Have we factored completely? Why not? Where? Which parenthesis are you thinking? Let's look at the first parenthesis first. We obviously don't have a greatest common factor in the first parenthesis, but do we have a difference of squares in the first parenthesis?
Yes.
Do we have a difference of squares? We have a sum of squares. We don't have a difference. What does difference mean? Subtraction. We have to have subtraction, and we don't have subtraction, do we? So we can't factor x squared plus 25 anymore. I'm just going to bring it down. That parenthesis is already factored. If that plus sign is there, you cannot factor using difference of squares. Now, what about this parenthesis? Is this a difference of squares?
No.
Yes, we have subtraction, we have a perfect square, we have a perfect square. So we can factor that. So let's set up 2 parentheses to factor that second parenthesis. The square root of x squared is x. And the square root of 25 is 5. All 3 of these parentheses are important. They are all part of your answer. You've got to be very careful and make sure you're checking your work as you go to make sure that you have it in completely factored form. did not factor that last step that we just did, it would be incorrect. You have to completely factor. Let's keep going. In this example, do we have a greatest common factor?
No.
I don't believe so. Do we have a difference of squares?
No.
We don't. So what do? We can't factor. That's correct. We can't factor. It doesn't have a greatest common factor. It has only 2 terms, so we can't do difference of squares because it's addition. So what do we say if it's not factorable?
Prime.
Prime. We say it's prime. This would be an example of something that's prime. Now, if you're able to do anything, even if it's just greatest common factor, it's not prime. Any type of factoring at all, it's not prime. But in this case, there's nothing we could do, so we would say prime. Example 8. Do we have a greatest common factor? Does 9 or 3 go into 64?
No.
I don't think so. Do we have difference of squares?
Yeah. Yes.
We do, so let's factor that way. What is the square root of 64x squared y squared?
8
8xy. What is the square root of 9?
3.
So we have 8xy plus 3, 8xy minus 3. Can we go further with either of these parentheses? We cannot. This is in factored form. Well, this example, a squared b squared minus 25. Do we have a greatest common factor?
No.
We do not, but we do have a difference of squares. What is the square root of a squared b squared? ab. What is the square root of 25?
5.
So ab plus 5, ab minus 5. With this example, do we have a greatest common factor? We do. What is it? It's 4. So let's factor a 4 out. Remember, when you do greatest common factor, we have 1 parenthesis, not 2, just 1. 4 divided by 4 is 1. You must put that 1 in there. 36x squared divided by 4.
9.
Minus 9x squared. Have we factored completely?
No.
No, what could we still do? Difference of squares. So bring down your 4. It's going to stay on the outside. And let's set up our 2 parentheses so that we can do difference of squares. The square root of 1 is 1. And the square root of 9x squared? 3x. So we have 1 plus 3x and 1 minus 3x. Remember, your plus and minus symbols could be flipped. I could put minus in the first parenthesis, plus in the second. It does not matter. Foot number 11. Do we have a greatest common factor?
No.
We don't. Do we have a difference of squares? We do. Everything is a perfect square. We can factor it. Set up our 2 parentheses to do that. What is the square root of 400x squared y squared? 20xy. What is the square root of 49a squared?
7a.
7a. Plus and minus. Can we factor anything else? Greatest common factor or difference of squares? We can't. How could we check our answers? I haven't really been mentioning that. FOIL. We could FOIL out our factor form. That should give us our original problem. Now remember, when we FOIL, those middle terms should cancel out. The O and the I should cancel out. Last example here. 25s to the 4th minus 9t squared. Do we have a greatest common factor? No. Do we have a difference of squares? Yes, everything is a perfect square. Now before we get too far, when we have 25s to the 4th, that's really 25s squared squared. Okay? So what is the square root of 25s to the 4th?
25s squared.
Is it 25s squared or 5s squared?
5s squared.
5s squared. What is the square root of 9t squared?
3t.
3t. So 1's plus, 1 is minus. Anything else we can do with either parenthesis?
No.
That's as far as we know. Okay, difference of squares. You're looking for what two things, Hannah?
If it has a subtraction.
And? Anything can help her out? We'll see what the thing. Well, in greatest common factor, we look for I'm thinking difference of squares. We look for a subtraction sign and what do those numbers have to be? Like what did 25 and 9 have to be? Perfect squares. Yes, they would have to be perfect squares. Those are the two things that you are looking for. If you have both of those, you are able to perform difference of squares.
So you look for greatest common factor first.
That's right. You will always look for a greatest common factor first, no matter what type of factoring you do. That always comes first. And then second, we'll either try grouping or we'll try difference of squares depending on how many terms we have. Let's abbreviate DOS for difference of squares. At this point, those are the only three methods we know how to factor with. We'll learn more next week. Okay. This is not what your worksheet is called. The worksheet is titled Factoring the Difference of Squares.